Have you ever looked up at the big, beautiful moon in the night sky? It looks so quiet and still, doesn't it? A calm, silent world just hanging out up there. But what if I told you it's not as peaceful as it seems? What if our moon shivers and shakes? And what if it once had giant fiery volcanoes, just like we have here on Earth? It might sound like science fiction, but it's pure science fact. The moon is a dynamic place with a fascinating history of geological activity. It's a world that has been shaped by forces from both deep within its core and from the vastness of space. So let's get ready to explore some of the moon's biggest, shakiest secrets. So, does the moon have earthquakes? Well, when they happen on the moon, we call them moonquakes. And yes, they are very real. Astronauts who traveled to the moon during the Apollo missions left behind special scientific instruments called seismometers. These are devices that can feel vibrations in the ground. For years after the astronauts came back to Earth, these instruments kept sending us data. They showed us that the moon is definitely not a dead rock. It trembles and rumbles in its own unique way. It's a bit like the moon has its own heartbeat, a very slow and sometimes shaky one, but a heartbeat nonetheless. These moonquakes are not exactly like the earthquakes we experience on Earth. Ours are usually caused by giant pieces of our planet's crust, called tectonic plates, crashing into each other. The moon doesn't have tectonic plates like Earth does, so what could be causing all this shaking? The reasons are very different and I think very cool. They tell us a story about the moon's relationship with the Earth, its own internal structure, and its long, long history. It's a cosmic mystery that scientists have been piecing together, one tiny tremor at a time, revealing a world far more active than we ever imagined. Thinking about a shaky moon naturally leads to another big question. What about volcanoes? Those dark, smooth patches you can see on the moon's surface are called maria, which is Latin for seas. Early astronomers thought they were actual oceans, but we now know they are vast plains of hardened lava. This lava had to come from somewhere, right? That's right, volcanoes. Billions of years ago, the moon was a much hotter place, with molten rock bubbling up from deep inside and spilling across its surface. This volcanic past carved out the face of the moon we see today, leaving behind clues of a fiery and violent youth. So let's dig into these moonquakes. Imagine a tiny shiver running through the ground. That's what a moonquake is like. The Apollo seismometers detected thousands of them. Scientists have sorted them into 4 main types, each with its own special cause. The first kind are deep moonquakes, which happen very far down, about halfway to the center of the moon. They are surprisingly predictable. They seem to be triggered by the gravitational pull of the Earth. As the moon orbits us, our planet's gravity squeezes and stretches it, causing the deep interior to crack and shift. It's like the Earth is giving the moon a little shake every month. The second type of moonquake is much closer to the surface. These are called shallow moonquakes. They are much more powerful and can last for a very long time, sometimes over 10 minutes. On Earth, a quake that long would cause incredible damage. These shallow quakes are also much less common and more mysterious. Scientists think they might be caused by the moon's crust slowly shrinking as its core cools down over billions of years. As the moon gets smaller, its brittle surface wrinkles and cracks, just like a grape does when it shrivels into a raisin. These are the quakes that could be a real concern for future lunar bases. Then we have vibrations from a completely different source, space itself. The third type of moonquake is caused by meteorite impacts. The moon has no atmosphere to protect it, so rocks and dust from space are constantly crashing into its surface. Even a small rock hitting the moon can send shockwaves through the ground that the seismometers can pick up. It's a constant cosmic bombardment, and each impact makes the moon ring like a bell. These impacts help scientists understand how often the moon gets hit, which is important for planning the safety of future astronauts and equipment on the surface. Finally, the fourth type of moonquake is the most unusual of all. They are called thermal quakes. These are very small shakes that happen every single lunar morning. How? Well, the moon's day is very long, about 2 weeks of sunlight followed by 2 weeks of darkness. When the sun rises, the frigid lunar crust, which can be as cold as minus 173 degrees Celsius, suddenly starts to heat up. This rapid change in temperature causes the rock and soil to expand, creating tiny cracks and tremors as the ground adjusts. It's the moon's way of stretching and waking up after a long, cold night. Now, let's journey back in time to the moon's fiery beginnings. Are there active volcanoes on the moon today? The simple answer is no. The moon is now considered geologically quiet when it comes to volcanic eruptions. The last major lava flows likely ended over 1 billion years ago. Today, the moon's interior has cooled down too much to produce the kind of massive eruptions that once created its dark seas. The energy just isn't there anymore. So you won't see a lunar Mount St. Helens erupting anytime soon. The moon's volcanic chapter for the most part is closed. However, the evidence of its volcanic past is everywhere. Those dark maria are the most obvious signs. They are enormous fields of a dark volcanic rock called basalt, similar to the rock that forms the ocean floor on Earth, or flows from volcanoes in Hawaii. These lava flows were so vast and fluid that they filled in giant impact basins created by asteroid collisions billions of years ago. This created the smooth, dark patches that make up the man-in-the-moon pattern we see. These ancient lava plains tell a story of a time when the moon was a hot, molten world, constantly reshaping its own face. Besides the giant lava plains, there are other, more subtle clues. Scientists using powerful orbiters like NASA's Lunar Reconnaissance Orbiter have found features that look like old volcanic vents and collapsed lava tubes. Lava tubes are tunnels formed by flowing lava. On Earth, they can be huge caves, and the ones on the moon could be even bigger. These giant underground tunnels might one day provide shelter for human explorers, protecting them from radiation and extreme temperatures. These features show us that lunar volcanism was complex, creating not just flat plains, but a variety of geologic structures. Here's a fun fact to consider. Some evidence suggests the moon's volcanic activity might not have stopped as long ago as we thought. Some unusual patches on the lunar surface, known as irregular mare patches, look much younger than the surrounding lava flows. They are small, lumpy deposits that might be evidence of more recent, smaller-scale volcanic burps that happened within the last 100 million years. While that sounds ancient to us, in geological time, it's quite recent. This makes scientists wonder if the moon's interior might still have a little bit of warmth left in it. So, we've learned that the moon shakes, quakes, and once glowed with flowing lava. That's pretty cool, but why is it important? What do these facts help scientists learn? Well, studying moonquakes is incredibly useful. The way the vibrations travel through the moon gives us a picture of its interior, almost like a doctor using an ultrasound to see inside a patient. From the moonquake data, we've learned that the moon has a crust, a mantle, and a core, just like Earth. It even has a partially molten layer deep inside, which helps explain some of the deep quakes. Understanding the moon's volcanic history is also key to understanding how it, and other rocky worlds, formed and evolved. By studying the age and composition of the lava rocks brought back by the Apollo astronauts, we can create a timeline of the moon's geological activity. This helps us piece together the story of the early solar system. It tells us how hot the moon was, how quickly it cooled, and what its chemical makeup was like. This information provides a vital reference point for understanding the formation of Earth, Mars, and other planets. The moon is like a preserved museum of planetary evolution. Furthermore, all this knowledge is essential for our future in space. As we plan to send astronauts back to the moon with the Artemis program, and perhaps one day build a permanent base, we need to know what we're getting into. Where are the safest places to build? We need to avoid areas prone to strong, shallow moonquakes. Could we use those ancient lava tubes as natural shelters? Knowing about the moon's geology isn't just for curiosity, it's a matter of safety and engineering. It's practical science that will help humanity take its next giant leap. Ultimately, studying the moon reminds us that the universe is a dynamic and exciting place. Even our closest celestial neighbor, which seems so unchanging, has a rich and active story to tell. Every moonquake and every ancient lava rock is a clue that helps us answer some of the biggest questions we have. How do planets form? How do they work? And what is our place in the cosmos? The moon isn't just a light in our sky, it's a scientific treasure chest. And by studying its rumbles and its rocks, we are learning more about our own planet and the incredible universe we all share. Consider that. If you enjoyed this journey through lunar science, don't forget to subscribe to our channel and hit the bell so you never miss an adventure into the cosmos.